Hello student, welcome to today's lesson. This is biology lesson for grade 12. In our today's lesson, we are going to see the new content which is ecological succession. Under this lesson, we are going to see ecological succession, biodiversity, and the population. Student, at the end of this lesson, you will be able to describe what is primary and secondary succession. And I will explain what is by mean ecological conservation to mean. And as well, we'll describe factors that affect population growth. Student, do you know what by means the term ecological succession to mean? Well done. When we say ecological succession, it is a gradual replacement of one community by another in a given stage or in a given sequence of stage. There is no life that can be found as it is. It can be formed through a gradual or progressive replacement of one community by another, following a stage which we call say. Under this one, there is an essence of succession. There is core key elements by which succession can be carried out. Here, the first community that can be invade or colonize this ecosystem is called pioneer community. During this one, there is no moisture, there is no soil, and again, there is no another favorable environment. The communities that can invade this unfavorable environment are considered as pioneer community, including lichens. Here, during this one, there is a primitive soil formation is found. When one community replaced by another, they can create certain favorable for next communities that are going to invade the area. Here, pioneer community, including lichens, become outcompeted by another community, which is considered as moss. When one community become pass, the next can create certain favorability for next stage, following the third stage. Then lichens become outcompeted by moss, where moss germinates there, and it changes the physical environment of the area, which is going to suitable for another community going to invade the area. The process continues. The process, one community passes, there is a change in a physical environment of the area, and the more species become entered into the area, and the process become continue until final community and a stable community become established. For example, here, a community that invade a bare rock where there is no moisture, when there is no soil again. Here, another community following the stage, third stage, lichens become outcompeted by moss. When moss become pass again, they forms a primitive soil, they forms another moisture, and again a bare rock of soil become formed here, and annual herb become formed again, perennial herb stage become formed here, finally the forest one become formed. This one community become pass, and they change abiotic condition of the area, and another community become outcompete until they establish this one. By that, we can say, according to the principle of succession, no community can be exist as it is. There is a gradual or progressive replacement of one community by another within a given time period, following a series stage. Well then, as a procedure of succession, when succession becomes passed, there is a complex ecological habitat become formed, because different organisms need different habitat. And again, the interaction, including the role of organism in a community, within an ecosystem become increased again. And again, more organisms become going to occupy this area. Here again, it is going to the interaction found between living organisms become going to complex. A food web become created. A food web become created again. Food chain become created here. interaction or relationship between living organisms become complex. As soon as they part here, the final and the most complex community which we call climax community created. Climax community to mean it is a final and the most stable communities that are created. It is a community that can survive within a changing environment with a good adaptation. Student, different area have different climax community because climax community of a given area can be affected by factor like temperature, factor like soil depths, factor like precipitation of a given area. This type of community never replaced by another community, but it can be affected by another environmental and the human factors. So, there is a community that can be replaced by another community. The way by which they can be replaced by another is for formation of climax community. Well done. So here, succession may be classified based on what type of stage or within type of conditions they can be created. The one is primary succession. When you say primary succession, it's succession that can be begun over a bare land when there is no primitive soil. Such a type of community is said to be pioneer community, which include lichens. A community that can be begun over volcanic eruption. A community that can be begun over uncolonized area, we call primary succession. When we say primary succession, the index of diversity of an area where they colonize is said to be too low. No other community occupies this area unless pioneer community. The second one is secondary succession. It is a succession that can originate when the area become destroyed by other factor like fire, like another human activity. We call this one is secondary succession. There is a succession before. When that succession become destroyed, secondary succession become encountered. Here again, student, both secondary succession and the primary succession progress to form climax community. Climax community is but too low because secondary succession may not be started over that of bare rock. They started over the area where primitive soil is found. And again, it may be the seed bank or root of the original succession or community may be found there. Here, there is a primitive soil formed together. As a result of this one, secondary succession is more rapider to arrive the same climax community. The rate at which secondary succession arrive climax community is much rapider because of this like factor. Well then, student, stage of succession. Each stage of succession can be change a physical factor of an area for the next succession going to invade. And again, species diversity of an area going to complex. And again, ecological niche and the feeding interaction come to complex again. Here again, the feeding interaction, including food web and the food chain come to complex. Finally, the communities to become climax and the more stable, not easily vulnerable to another environmental factor. This is what the common feature that all succession can be shared together. The another point that we are going to see together is biodiversity. Student, do you know what biodiversity mean? Well then, when we say biodiversity, it deals the variability of species, the variability in terms of genetics, the variability in terms of ecological variability because of the presence of different biome, because of the presence of many climatic zones, because of the presence of different latitude and altitudinal zones that Ethiopia is highly ecological diversified country. For example, we can find so many endemic species in Ethiopia. We can find so many bird species, mammal, amphibian species in Ethiopia. But this biodiversity is widely affected because of human-related activity, like deforestation activity for different purpose, cutting of forests for different purpose, and again for agricultural activity. For sake of overcoming food security, these two activities are human-related activities that rely over the loss of our biodiversity highly. By that, we human beings can affect our biodiversity more than any other species. If our biodiversity continue loss as a result of deforestation and agriculture in continuous manner, we may be encounter a worsening health problem. And again, we can encounter increasing insecurity of food supply. The problem of food supply may be encountered here. And again, vulnerable to environmental and human-related activity problem may be encountered here again. This is the problem that we can encounter as a result of loss of biodiversity. If our biodiversity continues in this manner, we may be affected by so much factors. What is expected from us is to conserve our biodiversity. Student, do you know what by means the term conservation to mean? Well done. Conservation to means using our biodiversity, using our natural resources in sustainable manner, considering there is a generation in front of us. The main thing how we can conserve biodiversity is in situ conservation. Second, there is ex situ conservation. When we say in situ conservation, we mean conserving our biodiversity within a site, within their original habitat, like maintaining national park, planting within a corridors, we call in situ conservation. When we say ex situ conservation, conserving biodiversity outside of the original habitat, we call off-site conservation, like botanical garden, like zoological garden, like gene banking system. We call this one is said to be ex situ conservation. Student, when we are conserving a plant, we can conserve all. This is done by planting a tree. If plant is planted, we can conserve soil, we can conserve our climate, we can conserve our rainfall, we can conserve everything if we plant a tree. And again, maintaining the protected area. If we conserve our biodiversity in this manner, our future generation become maintained. For example, planting a tree. Bird going to have a nest over the planted tree, and again another organism migrate toward this one to have their own habitat, just like the activities that Professor Lagase Nagash did within their tree propagation area. So, this conservation activity is not an individual action. It is a community action. An action that every individual, every society must be participated in. When you do this one, we can maintain our coming generation. So, conservation too means considering there is a generation in front of us. Another very important thing that we are going to see together is population. Student, what is population to mean? Well done. When you say population, it is a group of individuals of the same species that is found within a given ecological niche for a given particular time. At a specific time, within particular habitat, we call their population. To say they are a population, it must be interbreed. The two key features that each population can share together is they must be interbreed, must be produce fertile offspring. If an individual found in a given area for a given period of time can capable to interbreed in the produce fertile offspring, we call their population. So, population, just like that of an ecosystem, it is a dynamic unit. No population is static. there is a factor that can influence population. Population, just like an else, it can have its own density. It can have its own size again. So, population is affected by different factors. There are three main factors that can influence population size. The one is natality, amount born. The else is mortality, amount die. The else is migration, the one in migration rate versus immigration rate. Population migrating into an area, population migrating out of an area, out migration and immigration. Let's student, these three factors highly affect population size. When we say natality and the mortality, amount die and the amount born, it can affect both global and the local population size. Whereas migration can affect only local population growth or population size. Because if we are moving from Ethiopia to Canada or America, you're never going anywhere. We are moving within a globe that migration may not be affect a global population, but can affect a local population size. Well then, whether mortality, the natality can affect or increase or decrease population size can be determined by two main factors. These are biotic factor and abiotic factor. When we say biotic factor, it is an effect of living organism over a population. The effect of one population over another population. It is considered as a living factor. It is considered as a density dependent factor. So, the effect of one population on another population is said to be biotic factor. For example, the effect of population of predator over a prey. When prey population become increased, what about a population of predator one? When predator population become increased, what about a prey population? We call this one is, there is a living factor. There is a living factor together. And again, the effect of disease causing pathogen. Pathogen are a microorganism that can cause a disease. When microorganism become increased, the mortality become increased again. Population size come to decrease again. Another, there is a competition again. Competition is another biotic factor. Population can be compete for each other for a resource. This competition may be classified into two main types. One is intra-specific competition. The else is inter-specific competition. When we say intra-specific competition, a competition of the same species for a given resource. A competition between the same species is considered as intra-specific competition. When we say a competition between different species is considered as inter-specific competition. So, these three are the main biotic factors that can affect population size. Another factor is considered as abiotic factor. This is considered as a physical factor. It is an effect of physical factor over a population size. These two factors can influence population. For example, the effect of temperature over a population, the effect of light intensity over a population, the effect of soil over a population, effect of carbon dioxide and oxygen concentration over a population size, the effect of water availability over a population size. We mean this is a physical factor. Well then student, all population can be grown in the same pattern again, in the same way, until their growth is limited by environmental resource. No population can grow beyond environmental resource. Population can be grown until the environmental resource can allow them to be grown. Based on this one, population can be grown by two main patterns. The one is arithmetic growth. The second is exponential growth. Student, do you know what is the difference between these two patterns of population growth? Well done. When we say arithmetic, population grow by the same fixed number. Population can be grow within a fixed number, the same fixed number within a given period of time. We call arithmetically. For example, if population can be grow in saying 1, 2, 3, 4, we call it is arithmetical growth. No as much population growth may be found here because it can grow by the same fixed ratio. Use uniform fixed ratio here. When you say exponential population growth, it means a doubling population growth. Mostly bacteria can be grow by this manner, showing a J-curved population growth. For example, growing in this manner, 2, 4, 8, 16. Let me see graphically this one. There is 3 main lines that indicate pattern of population growth here. This red line indicate population can be grow arithmetically. Arithmetic population growth. The population size not as much grow. The population size doesn't increase as much. Whereas here a yellow line can be indicating again exponential. Exponential population growth. Where again this green line can be indicating again highly increasing population number exponentially. Population can grow until limited by environmental resources. Here, the number of population by green line is highly increasing when compared to that of the number of population indicated by yellow line. And again, the number of population indicated by red line is not as much. If certain graph can be given for you, you can easily identify which pattern of population growth they can follow. Well done. As a result of combination of biotic and abiotic factor, as the impact of living in the non-living factor, all population can be grown through 4 main phases. This is a consecutive phase of population growth. One is lag phase. When we say lag phase, population going to establishment of population into new environment. Entry into new environment is said to be lag phase. When population enter into certain new environment, it may be adapt, it may be not. Under this one, population number may be slowly grow. Slow population growth may be found here. Under a log phase, population may be grow very rapidly. When population become going to adapt into that of the environment they enter. When there is a plentiful resource for population. When there is availability of resource for population, population can show an exponential growth. Exponential growth here. We can say it is an exponential population growth. The number of growth may be greater than the number die because good adapted to that of the environment where they enter. Plentiful environmental resource here. Another is, even though population can be grow in this manner, no population can be grow beyond the environmental resource. There is a maximum until which population can be properly grow. Population can be grow until a stationary phase. A stationary phase means when carrying capacity maintained here. Carrying capacity. When we say carrying capacity, it is a number of environmental resources that can capable to sustain a given population in a given time period. We call this one is carrying capacity. If carrying capacity reached or entered, population growth may be fluctuate at mean level. Nearly the number born and the number die may be balanced here. Even though population can show certain pattern of growth, no population can grow above carrying capacity. We call this one is an stationary phase. Static phase here. Static phase. Here, when the environment or natural resource going to toxic to the population, we call they enter into that of decline. Decline phase. The 4th phase of population growth. Here, nearly, we call this one is a lag phase. entry phase. This one is a log phase. When population become plentiful to the environment, J curve here. This one is a stationary phase. Stationary phase here. Whereas this one is decline phase again. Student, remind again, this stage is unorderly arranged. Log, stationary, and decline. All population grows through these four main phases. No population can be grow above this carrying capacity. Because of this carrying capacity, population number become grow statically, fluctuate at mean level. Additionally, we can represent a population of a given country. How much young people is there? How much older dividing group is there? What is the sex ratio of a population is there within a given country based on age pyramid. It is a graphical representation of a difference between young, old, male, female within a given demographic tradition. We call this one is age pyramid. Student, do you see certain difference between this pyramid? Which pyramid may represent an Ethiopian or a developing country? Well then, this one is considered as an expanding pyramid. There is at the bottom expanding here. The number of births is greater here. Here, the age group that's found around here is much higher. Children birth is highly encouraged here because of religious encouragement, social encouragement, and again the number of days is become high. The number of life expectancy of this type of pyramid is too low again. The per capita income of this country become low again. By that we call this one is an expanding pyramid, broad at base pyramid. Whereas this type of pyramid maybe shows certain change of population growth. Here, population just like that of USA. And again, this may represent Italy. Italy. When we see here, there may be a change in population size. Still, but it shows certain contracting here. Decreasing population size may be observed here because availability of nutrition may be found here. Availability of family planning may be found here. Stationary pyramid. One, young productive group is found here. Young productive group. And again, highly older dividing group is found here again. And again here, the amount born is going to minimize here. Static. Nearly amount born and the amount die get balanced here. Even though there is a population growth, population can be grown in a statical manner. So, we can group a given country in a given demographic transition according to age pyramid. A pyramid that represents developing country. Here, high children born and they die earlier. And again, low life expectancy is found here, contracting. The one that represents just like that of USA. Even a population can be growing here, certain change can be found here. And again, the else is a stationary pyramid. When you say stationary, a balanced growth, less dependency ratio, high per capita income, and again, high life expectancy may be found here. A country just like that of Italy. So, population can be represented pyramidically. To limit population growth, it must be free contraception program must be available. Free family planning activity must be available because population size may be influence a country development. And again, free sex education must be available for a given country. And again, better provision of agricultural resource. And again, better availability of food supply. And the quality, the quantity must be available to be limit population size growth. Student, in our today's lesson, we have seen what is ecological succession to mean, the essence of all succession, and the difference between primary and the secondary succession. And we have seen Ethiopian biodiversity, why Ethiopia is considered as a biodiversity rich country, and what is expected during biodiversity conservation, and the difference between in situ and ex situ conservation. As well, we have seen population and the factors that affect population growth, including biotic and abiotic factor. Finally, we have seen a difference between lag phase, log phase, stationary in the decline phase of population growth. This is all about today's lesson. In our coming lesson, we will see new unit, genetics. Until that, goodbye, students.